Welcome to the Geo-Strategic Podcast.
Welcome back to the deep dive. Just hours ago, a U.S. Doomsday Plane, the E-6B Mercury, vanished over the Atlantic. This isn't an ordinary jet. It's the aircraft built to transmit nuclear strike orders if the worst ever happens.
Why did it suddenly go dark, cutting off all flight tracking? And what secret mission could be unfolding right now?
We're breaking down the facts, the strategy, and what this means for global security. But first, make sure to like this video, subscribe, and turn on the bell so you never miss critical updates like this.
And I want to hear from you. Seriously, drop a comment below with your thoughts.
Was this just routine or something far bigger?
Let's dive in.
Okay, let's get right into this, because when an E-6B Mercury drops off the map, it definitely gets people's attention.
It's designed to. The alarm bells you hear are, in a way, part of the message.
Exactly. So we're talking about a very specialized plane. There are only, 16 of them in the whole fleet?
16 in total, yes. And they serve as this mobile command post for U.S. Strategic Command.
And for the highest levels of leadership, the Secretary of War, even the President.
Absolutely. If ground-based command centers go silent, this plane becomes the nerve center. It's the ultimate backup.
The ultimate insurance policy. And that gets to its mission history, right? This isn't a new concept.
Not at all. The E-6B is just the current version of a mission that goes way back. We used to call it Operation Looking Glass.
A classic Cold War name.
It is. The whole idea was to have a command post always in the air, 24/7, to guarantee that we could retaliate, even after a surprise first strike.
So it's not just a fancy radio relay. It's a flying war room.
A fully functional one. And its main job, its whole reason for being, is tied to this concept called TACAMO.
Take charge and move out.
That's the one. TACAMO is the system, the function that connects the president directly to the entire nuclear triad.
The bombers, the land-based missile silos, and of course, the submarines.
Especially the submarines. The SSBNs, they are the most survivable part of that triad because they're hidden deep in the ocean.
So getting a message to them is the absolute top priority.
It is the critical link. And that brings us to the really fascinating part of this plane, the technology inside it.
Right, the fact that this $140 million aircraft is deliberately running on old analog tech.
It seems counterintuitive, doesn't it? Why use tech from the 80s instead of the latest digital systems?
Because the new stuff is too fragile.
Exactly. The biggest threat in a nuclear scenario, aside from the blast itself, is the EMP, the electromagnetic pulse.
And that pulse, what does it actually do to modern electronics?
In simple terms, it fries them. A high-altitude nuclear detonation creates this massive wave of energy.
And the tiny transistors in our phones and computers just can't handle it.
They get overloaded instantly. The surge is just too powerful. But older analog components, things like mechanical relays, heavy-duty wiring, they're built differently.
It's more robust.
Far more robust. So the Mercury is shielded, of course, but it also uses this obsolete tech precisely because that makes it immune to this very specific, very high-tech form of attack.
A strategic choice. To embrace legacy hardware for the highest stakes imaginable.
It's the only way to guarantee the deterrent is credible. The promise of retaliation has to be believable, and this plane makes it so.
Okay, let's pivot to the event itself. The plane, call sign AFD FE2, disappears. What was its flight path just before that?
It was all very routine, which is interesting. It took off from Naval Air Station Patuxent River in Maryland.
Flew over the Chesapeake Bay, went past the big naval complex at Norfolk.
Yes, and then it headed out over the Atlantic. The last public signal was picked up around 8:30 in the morning, Eastern Time.
About 60 miles off the coast of Virginia.
That's right. And for anyone watching on a public tracker like Flight Radar 24, it just vanishes.
Which sounds terrifying. But you're saying this is actually standard procedure.
It is completely standard for this kind of mission. When we say it went dark, we just mean it stopped broadcasting as public signal.
It switched off its ADS-B transponder.
Exactly. It entered its classified operational mode. You don't want your adversaries to know exactly where and when you're running these critical tests.
So once it's invisible to us, what is it actually doing out there for the next, say, 4 to 8 hours?
It's testing that VLF communication link.
VLF. Very low frequency.
That's right. It flies into a specific, pre-planned military warning zone, and then it gets ready to deploy its most important tool.
The trailing wire antenna.
The famous trailing wire antenna. There are two, but the main one is, well, it's enormous. It's nearly 5 miles long.
5 miles? How does that even work?
The plane has to fly in these very specific patterns, these slow, wide ovals, to keep the wire almost perfectly vertical as it trails below the aircraft.
A giant hanging antenna in the sky.
Essentially, yes. And it has to be that long because of the physics involved.
To communicate with the submarines.
Correct. VLF waves are one of the only frequencies that can actually penetrate salt water to any significant depth.
So the subs don't have to surface and give away their position.
They can stay deep and hidden, but to transmit on that VLF band effectively, you need an antenna that is proportionally huge. That 5-mile wire turns the E6B into the most powerful airborne VLF transmitter on the planet.
So for hours, it's just flying in circles, sending secure test messages down into the ocean. It's a drill.
A very complex, very important drill. And think about the timing here.
This happened the day after Thanksgiving.
A major national holiday, a time when you might expect operational tempo to be a little lower.
So launching this mission right after Rees sends a message.
It sends a very clear message. Internally, it shows that the command structure snaps back to full readiness instantly.
And externally, to any rivals watching.
It tells them that our vigilance is constant. Doesn't matter if it's a holiday. The deterrent is always active. It reinforces that idea of assured retaliation.
It's all about maintaining that continuity of command, proving the system works.
Precisely. If an adversary ever thinks they could launch a decapitation strike and cut the head off the snake, so to speak, then deterrence fails.
The E6B is the flying physical proof that the connection can't be severed.
Especially the connection to the submarine force, which guarantees that second strike capability.
And these missions don't just happen over the ocean. We've seen these planes in the middle of the country, too.
Oh, absolutely. There was a sighting back in March near Omaha, Nebraska.
Which is not a coincidence. That's home to Offutt Air Base.
The nerve center for STRATCOM's nuclear command and control. So when an E6B flies around there, it's testing its ability to link up with or even take over from those ground-based centers.
So it's a fully integrated system, air and ground.
Seamlessly.
And looking at the past week, this flight on Friday wasn't the only one. There's been a real flurry of activity.
There has. Flight trackers saw 3 other Mercury planes active just on Monday.
But those were different kinds of flights, right? Shorter, more localized?
Very different. One was circling near Tulsa, another flew south towards Dallas, and one took off from Maryland.
Not the long, over-ocean VLF mission. So what would be the purpose of those?
It suggests they're testing other parts of the system. Shorter flights like that are likely for internal checks, crew training, or maybe communicating with different ground stations.
Testing satellite links, maybe?
Yeah.
Or other radio systems?
It could be any number of things in the C3 network: command, control, and communications. The point is, the whole fleet is active, testing different components of the chain.
So it's not just about one plane going dark. It's about a fleet-wide readiness exercise.
That's the strategic intent here. Whether it's a long drill over the Atlantic or a short check over the Midwest, the message is consistent.
That the mechanism works. It's well-oiled and ready.
And that the ability to issue those orders will survive anything thrown at it. That's what makes the deterrent credible.
It's such a fascinating look at a system built for one thing, survival. But let's go back to that paradox you mentioned, the reliance on old tech.
It's a huge strategic tension, isn't it? The most important command system we have, the one that guarantees the survival of the state, depends on components from the late 80s.
Using design principles from even earlier.
And it has to. It's built to defeat the very high-tech weapons it would face. It's choosing durability over digital sophistication.
Which leaves us with a really provocative question, something for you to think about.
If this strategy works for our most critical command link, hedging against EMPs with analog tech, what other essential systems might be doing the same thing?
Things like power grids or maybe financial networks.
Or other specialized military hardware. What other critical infrastructure secretly relies on older, outdated technology because it's exponentially harder to hack or disrupt than its modern digital equivalent?
It makes you wonder, maybe the key to future security is sometimes found in the past.
It's something to consider.
A very powerful thought to end on. Thank you for walking us through the tech, the strategy, and the real meaning behind the E6B going dark.
My pleasure.
And thank you so much for listening or watching this deep dive. If you want to learn more about the world's hidden strategic assets, please check out the other deep dives we have available, and we'll catch you on the next one.
If you found this discussion valuable, please like, share, and subscribe to the Geo-Strategic podcast for more in-depth analysis on topics that shape our world. Stay informed, stay ahead, and stay tuned for the next episode.